Earth science time. Glacier time. Glacier time. Write down glacier, please. Glacier. Okay. You know what a glacier is. You've seen.
Ice Age.
Okay, you've seen Ice Age. What up with glaciers? Okay. Slow, big, massive ice. Let's just write that. Slow, big, mass of ice. Specifically, first of all, what kind of ice?
Frozen water.
Water ice, yeah. What sometimes we really do, I mean, generally in Earth science and this planet science, we just say ice, but this is specifically water ice. Other planets, and even Earth, have different kinds of ice of different materials, but when we say ice, we mean water ice. Slow meaning what? Slow like when you crawl? Like, no, I think you're thinking of an iceberg, but slow on the order of what? Like, what kind of units would we measure?
Not the same thing.
No. What kind of, probably not, unless you're going to use very small numbers. What kind of units would we use to measure the speed of a glacier if we were using, like, whole numbers? If we wanted to do, like, no.
Inches per hour.
What?
Try again.
Centimeters per hour.
Centimeters per...
Millimeters.
Per day.
Per year.
Maybe centimeters per year would be a little bit too slow, but centimeters per week maybe, or centimeters per day, depending on the size and the speed of the glacier. So glaciers are a slow, big mass of ice, and in fact we use the adjective glacial to mean when something is moving very slowly. Like you might think to yourself during a class that isn't this one, you might think, oh, this class is moving at a glacial pace, which means it seems to be going very slowly. Or you might, someone might, I don't know, what kind of jobs do people do for you? Like Colby and Jacob might be mowing your lawn, and you're thinking, they are moving so glacially because they're getting paid by the hour. And they know if they take 4 hours to mow my lawn, I'm going to owe them $80. Is that their correct rate?
I guess.
Okay. You don't do that though. You don't screw people out of their money by taking too long. Okay. There are two kinds of glaciers, or there are lots of kinds of glaciers, but there are two broad categories of glaciers, and they are valley glaciers and continental glaciers. And we're going to talk about both, so leave a little space in between them. All glaciers. Both of them are slow, big masses of ice. There's kind of like a rhyming thing that I sometimes do to define these. So valley glaciers. So first of all, what kind of physical criteria do we have to have for a glacier to form? It has to be what?
Frozen.
Cold. Yeah, it has to be cold. And where do we find cold places that are cold year-round? Because we'll talk about in a second how glaciers form. But, okay, not only Alaska, not specifically Alaska.
Antarctica.
Okay, so once again, that's too specific. But places that are cold are generally where on the map?
By the poles.
Near the poles, which we would say they have a high what?
Velocity.
What do we call it when it's nearer to the North Pole or the South Pole? High... What? Say it again?
Degree.
Yeah, high degrees of...
Latitude.
So continental glaciers usually have a high latitude, which means they're nearer the poles, right? Because we measure latitude in degrees from the equator. So the higher those degrees get, the nearer it is to the pole. So high latitude, either north or south, right? High latitude is nearer the poles. And valley glaciers, someone else had a different thing. So where else do we find places that are cold year-round? Like, can you travel within 500 miles of here and find somewhere that's going to have snow year-round?
Montana.
Maybe, yeah. So, but places that are what? Not high altitude. Yes, high altitude. High altitude, meaning they're up high in the sky, right? Like a mountain range. So valley glaciers are because it's cold at high altitudes, and continental glaciers exist because it's cold at high latitudes.
That's all we're writing in those?
No, there's going to be more, but this is just like a little, like I said, poetic rhyming thing. Altitude and latitude technically rhyme, and they rhyme with attitude, which is what you people got. That's what I got. Okay.
You got that.
So, valley glaciers form in high altitude, which is like where? Where do we find high altitudes? At the tops of?
Montana.
No, not just Montana. Stop being so specific. Yeah, mountaintops. So form in the mountains. Sure, we'll just put that. Form in the mountains. Continental glaciers, you can tell probably just from the name, they form over large areas of land, which we sometimes call continents, form over large areas of land. And this is important. The distinction is important because which one of these do you think generally has the higher slope?
Valley.
the valley glaciers will have a higher slope because they're forming in a terrain that is inherently uneven, right? So oftentimes they form on slopes, whereas continental glaciers are forming over flat areas of land, right? So, and knowing what we know about erosional media, if this generally has a higher slope, not always, but generally has a higher slope, which of these probably moves faster? The valley glaciers, because they have a higher slope, right? So these tend to be, and once again, not always, but tend to be faster, right? And so, well, and they're both glaciers, they're moving glacially, but this is faster. That's like saying that of the movie Dumb and Dumber people, which I've seen a long time ago and I don't like it. Who are the people in Dumb and Dumber? You know, have you ever seen that movie?
Yes.
Yeah.
You don't like it?
If you say one of them is smarter, right? It's not saying a lot. Just like saying this is not saying that they're actually fast, but it's faster, right? That's not a very good example. I wish I had thought of a better example than that. I'm sorry. Okay. So no, hey, don't be mean to your friends. Okay. So just like we did with Aeolian erosion. So these are the places that glaciers can form, and now we're going to talk both about glacial. Oh, I should have put this on picture-in-picture a long time ago. Sorry, there we go. We're going to talk about both glacial erosion and guess what else? Can you think of what else I can talk about?
Weathering.
No, that's a good guess though.
Deposition.
Deposition. So, I feel like I say so a lot. Like whenever I'm about to start a new paragraph, I'm like, so.
Do you like sewing?
Yeah.
I'm not good at sewing, but sometimes I have to do it. Anyway,
Really?
in glacial, yeah. What? Yeah, I gotta put like a button back on. I wear a lot of buttons in my life. Okay, so glacial erosion, as we know, glacial erosion is where material is carried away, in this case, obviously, by a glacier. And I want to show you some pictures. If you're watching this on, what's the website? YouTube.com? If you're watching this on YouTube, you can look these up with your little search engine, Owen.
Oh, yeah.
Yeah. Go to searchengine.com. But you have, I want you to look at page 209. We're going to talk about cirques, horns, and hanging valleys.
Is that
So
an erosion? Or?
these are erosional features. In the same way that we had ventifacts as erosional features of Aeolian or wind erosion, we have these three as artifacts. We wouldn't call them ventifacts, but as physical manifestations of glacial erosion. So the first thing we talk about is this U-shaped valleys. We talked once before about, I don't like this marker anymore. We talked once before about, we talked once before about valleys that can form, right? We said that glaciers have U-shaped. What kind of thing forms a V-shaped valley? Do you remember? Water. Yeah, rivers specifically, usually. Because what happens is, there will be some, generally, if we're looking at some mountains, this is like how a child might draw mountains. Let's put a little, nice. This is how glaciers form in general. Year after year, snow falls, right? So every year here, snow falls. And then it does what? Melts. But in places, either because of high altitude or high latitude, that the snow doesn't melt, it not only stays there, but every year more snow falls on it, and it gets compacted, forming a big old block of ice, which we have a name for, and it's glaciers. So over time, this glacier builds up by layer in the places in between these two mountains, right? And as it does that, its own weight starts to drive it down the mountain. Like the mountains are sloped in this direction too, and so it starts to scoop out that. And as it moves, it scoops out this U-shaped valley because of the pressure it exerts. So it forms this U-shaped valley. If you're ever in an environment where, I'm trying to think of where you might see this, but if you've ever been to, the video we're going to watch is about Yosemite. If you've ever been to Yosemite, those valleys are U-shaped. They have fairly steep walls and a fairly flat, what we call a floor. Whereas like the Grand Canyon or something like that, we have, this is not what's going on here, but we have this V-shaped valley where the river has cut down. And we'll talk about V-shaped valleys in the next chapter. But anyway, so these U-shaped valleys formed, and lots of times there's more than one, especially in the valley glaciers. There's lots of times more than one. And so if we have two of them meeting on either side, they're going to dig out this little mountain in the middle so that eventually it looks like this, right? So it's got steeper sides than a mountain normally does. And we call that a cirque. It'll be kind of long in this direction, kind of long in that direction, but it's got steep sides. Do you know what I mean by long in that direction? Like, it's not, this looks almost like it's like flowing off into the wind, but I'm trying to draw it three-dimensionally. So like front and back, it's long and skinny, but it's got steep sides on either side of it, okay?
Yes.
If the same thing happens, but there's three glaciers, one back behind it, I keep drawing just lines over top of that, but it forms, instead of a long and skinny thing, it forms just one single point.
That's called a horn.
And that's called, as Levi correctly mentions, a horn. The picture here is of something very famous called the Matterhorn, which is a mountain in the Alps in Sweden. I'm sorry, Switzerland. Don't get that wrong again. It's in Switzerland. Have you ever eaten the candy Toblerone?
No.
Okay.
Sounds
Have you ever heard of the candy Toblerone?
No.
It's got a yellow triangle box.
You're just
It's at the Dollar General.
Yes.
Yeah, it's good.
Do they
My
come
grandma
big?
likes those.
Yeah, they come enormous.
You know where's in the yellow and gold?
And
Yeah.
they're all
Maybe if you're lucky, I'll bring you one.
And that's
They're
square
little
little
triangles, yeah, and they're shaped like the Matterhorn. In fact, the logo is the Matterhorn. I'll bring you one to eat sometime, and then I'm going to eat them all, and you can watch. Okay, so there's a cirque is what happens if two glaciers are kind of running parallel to each other, scooping out the sides of this peak, and the horn happens when there's three that kind of meet and form a single location. The third type is this hanging valley, where if we have these two glaciers, or maybe just one, and another glacier is coming the other direction, but it's at a different elevation, we end up with this, I'm going to erase both of these, we end up with this U-shaped valley on top of another U-shaped valley. So we'll pretend there's like a valley down here going this direction, and there's another one coming out. It looks a lot better in your picture, and there's even a beautiful, majestic waterfall coming out of it.
That's kind of cool.
It's called a hanging valley. So this thing here is the hanging valley. And so basically all the glacial erosional features are just different congregations of two or more glaciers that have met and formed something. Okay?
So the horns form like when
When three, and I only got the two hands, but there's one coming this way like my marker, one coming this way like my hand, and the third one where my this hand is going, and they kind of meet and form this triangular and cross-section peak. And then the hanging valley forms, this is really not a very good way to do this, but it forms when there's like a glacier moving this way, and then a higher one at a higher elevation moving this way, and when they meet, there's like this gap here which forms a hanging valley. Okay. Glacial deposition, the most important and the one that's talked about the most is something called a moraine. And this is basically, as a glacier moves along, it's like a bulldozer, and it just scooches every single thing out in front of it. Do you remember what kind of sediments we said can be moved by a glacier? Can move boulders. Does it only move boulders? No, every single thing. So if we look at the glacial deposits, which the moraine is like, if you imagine a bulldozer, the big old pile in front of the bulldozer is called the moraine. And this has boulders in it, it has little pebbles in it, it has sand in it. You think it has silt?
Yeah.
Yeah, boy, it's got silt. What else do you think it's got?
Clay.
Clay, yeah, all the sizes of sediment. It's what we would call something sorted sediment. What do you think?
Unsorted.
Sure. Yeah, I was going to say poorly sorted, but unsorted is probably even better. Unsorted sediment. Unsorted sediment. It says glaciers deposit unsorted ridges of till, and sometimes we call this glacial till. What was the other thing we said that could move boulders? Glaciers and? Remember from
water.
maybe very fast-moving rivers, but primarily rock falls, right? The mass movement that we called rock fall. So if you're in a place and you see a boulder, one of two things happen. Either it fell down off a mountain, right, as a rock fall, or a very fast river moved it, or usually, if it's out in the middle of a field somewhere, this is a place where a glacier used to be. Like if you go to Minnesota, we don't ever have to deal with this here, but farmers in Minnesota are like, I gotta move this boulder, right? Because I don't want to plant where the boulder is. This doesn't ever happen here because there have not been glaciers here since Snowball Earth more than 500 million years ago. So this is just a problem we don't have.
Is that a good thing?
Yeah, well, I mean, if you ever don't want to move a boulder and you don't have to, that's better than if you do have to. So there's also this idea of outwash, where as the glacier, even though it builds up every year because the snow doesn't melt, the glacier does melt a little bit, right? Every time it gets warm, it doesn't, when I say that the snow doesn't melt back here when we talked about that, it does melt a little bit. It just never completely goes away, right? So every summer when it gets a little bit warmer, it does melt. And this outwash is the sediment carried by meltwater. And how do you think the sediment carried by meltwater is going to act? Like, what kind of sediments will be carried by the meltwater?
So like small. Like,
Yes. Same as like what would be carried by a river of the same size. Maybe sand if it's moving quite quickly, maybe just silt. But it will be, as opposed to the moraine deposits, it will be sorted. This will be sorted sediment. Of any particular size, right? Probably not larger than sand, but it will be sorted. And then three common but probably less important features of glacial deposits are kames, eskers, and drumlins. I'm just going to read you what they have because I've plumb run out of room, so listen up. Kame, it says, kames are short, cone-shaped mounds of sorted deposits. They are shaped from outwash left as the glaciers recede. So the same kind of thing as what I just talked about, except this happens when the glacier is backing up, right? It just leaves these little piles of sorted sediment. Those are called kames. Eskers are long ridges of sorted deposits. They are shaped from outwash deposited by water flowing through tunnels in the glacier, which is kind of neat, right? The glacier's got these holes in it, and as the water flows through these holes, it leaves behind, same thing, sorted sediments, but if they're long and skinny, we call them eskers. And then drumlins, it says, are shaped as the glacier moves over old moraines. So we talked about moraines, which are these piles of unsorted sediment. As the glacier runs those over, like it advances further, it makes them into just hills of unsorted sediment, which we call drumlins. Do you have questions about any of those? Those are all vocab words. Do you have questions about glacial deposition in general?
No.
You had already asked questions about glacial erosion, but have you got up some new ones? What about glaciers in general? Okay. If you got a question, you can ask it in the comments. Actually, I turned off the comments, so you can't. Sorry, email me.